Are we living inside a black hole? It sounds impossible, but the deeper you look, the less impossible it seems. And if it is true, it could explain the Big Bang and mean that everything you see and touch is a hologram. Let's start with what a black hole really is. It's not a hole in space. It's a region where gravity becomes so strong that nothing, not even light, can get away. That happens when a massive star runs out of fuel. The star's own gravity pulls everything inward and it collapses under its own weight. All that matter gets squeezed into a space that's unbelievably small and dense. There's a point around a black hole called the event horizon. You can think of it as the edge of no return. Once something crosses it, it can never come back out. Not a planet, not a spaceship, not even light. That's why black holes look completely dark. They trap everything, even information. At the very center of a black hole is what scientists call the singularity. It's not really a place the way we normally think of one. It's a point where gravity becomes so intense that space and time, as we understand them, stop working. The math that explains how the universe behaves everywhere else simply breaks down there. We can't describe what's happening inside that point because the rules we know don't apply anymore. Now think about the universe. It isn't sitting still either. It's expanding. Galaxies are moving away from each other, not because they're flying through space, but because space itself is stretching. The farther away something is, the faster it moves from us. Eventually, there's a distance so great that light from beyond it will never reach us. That distance marks the cosmic horizon, the edge of what we can ever see or know. That already sounds familiar. A black hole has an event horizon, and our universe has a cosmic horizon. Both are boundaries that light and information cannot cross. Inside both, time and space act differently from outside. In one case, gravity pulls everything inward. In the other, expansion pushes everything outward. The shapes are different, but the patterns are the same. This is what led some physicists to a bold idea. What if our entire universe exists inside a black hole that formed in another universe? To understand how that could work, let's go back to the beginning, the Big Bang. Most scientists believe the universe began about 13.8 billion years ago in a state that was extremely hot, dense, and tiny. Everything that exists today was once packed into a single point, smaller than an atom. Then, suddenly, it began to expand. That's very similar to what happens inside a black hole, only in reverse. When a black hole forms, matter collapses into a single, dense point. But if you were somehow inside that process, you might see the space around you expanding instead of collapsing. In other words, the same physics that describe the end of a star could also describe the birth of a universe. Einstein's equations actually allow for this. They describe how massive objects bend space and time. When you apply them to a black hole, they don't only predict a collapse, they also describe new regions of space forming inside the event horizon. To an observer outside, the black hole looks like an ending, but from inside, it could look like a beginning. Some scientists have suggested that when a black hole forms, the matter falling in doesn't just disappear. Instead, it could create a new expanding region of space within it. That region would be cut off from the original universe by the event horizon. From the inside, that new space might look exactly like our universe expanding after the Big Bang. This idea means that every black hole could be the birthplace of a new universe. And if that's true, our universe might be one of many, part of a long chain where each universe gives rise to others. The idea also helps explain why our universe looks so balanced and uniform. The leftover glow from the Big Bang, called the cosmic microwave background, is almost the same temperature everywhere we look. That smoothness is hard to explain if the universe started from random chaos. But if it began from a single, compact point like the core of a black hole, that would naturally spread energy evenly as it expanded. There's also a link to quantum physics, which describes how things behave at the smallest scales. When we try to combine Einstein's theory of gravity with quantum theory, strange things happen. According to some versions of quantum gravity, space and time are not continuous. They're made of tiny, indivisible units, like pixels on a screen. That means that instead of collapsing forever into a singularity, the matter inside a black hole might reach a limit where it can't compress anymore. When that happens, it could bounce outward, starting a new expansion. That bounce might look to us like a Big Bang, the beginning of a new universe forming from the ashes of a collapsed one. If that's true, then black holes aren't just cosmic destroyers, they're also creators. Every time a massive star dies and forms a black hole, it could be giving birth to something new, somewhere beyond its horizon. Now think about what that means for us. If our universe is inside a black hole, everything we know, every star, galaxy and particle, is inside a kind of cosmic boundary. Beyond it, there might be an older universe we'll never see. That outer boundary would be the event horizon of our parent black hole. We can never cross it or send a signal through it. Everything that happens beyond it is forever out of reach. At first that might sound limiting, but it can also feel deeply connected. It means our universe isn't floating in isolation. It's part of a much larger structure, a web of universes linked through black holes, each one growing out of another. This also changes how we think about the words inside and outside. If space itself can curve and fold, then those words stop meaning what they do in everyday life. In a curved universe, there may be no true center and no real edge. Everything is contained within itself. So in a sense, we aren't just living inside the universe, we're part of it, made of the same matter, moving through the same curved space, shaped by the same forces that guide galaxies. It's true that there's no way to test this theory directly. We can't see beyond our cosmic horizon and we can't look inside a black hole. But the fact that these ideas come from real physics, not pure imagination, makes them worth exploring. They challenge what we think we know about beginnings and endings. If every black hole can form a new universe, then every ending contains a new beginning. A dying star might be the first spark of a new reality. Creation and destruction would no longer be opposites, but parts of the same cycle. And maybe that pattern continues even further. Maybe our parent universe came from another one before it, and maybe the black holes in our universe will each lead to their own. That means the cosmos could be infinite in depth, even if each universe has a boundary. Even if this theory turns out to be wrong, it's still valuable. It stretches our imagination. It helps us see that the boundaries we believe in might not be real. It shows that curiosity itself is part of what keeps the universe alive, not just in matter, but in thought. Maybe that's the real lesson. The universe might not have an end, but our knowledge always has edges, and every time we reach one, we push a little farther, just like the universe itself expanding into new space. So, are we living inside a black hole? Maybe. The truth is that we don't know, but the idea shows us something even more powerful, that creation and mystery are always linked, that every collapse could be a new beginning, that what seems like an end might only be the start of something larger. And that's what makes the universe so beautiful. It's not just the stars or the galaxies or the vastness of space, it's the fact that even with all we know, the greatest mysteries still live just beyond our horizon, waiting for us to ask again what might be on the other side. Do you think we're living in a black hole? Comment your thoughts down below, and don't forget to like and subscribe while you're there.